Hello guys, good morning. Welcome to the session of Organic Chemistry KVPY. Okay, so we are going to discuss today a new type of reaction, that is elimination reaction. Okay, in the previous session we have discussed about the reaction called substitution reaction. We have discussed SN1 and SN2. There are other types of substitution reaction also, right, which we'll discuss later on in when we do this in the class. But for the KVPY exam, SN1 and SN2 is sufficient enough. Okay, so let's try and understand this reaction, that is E1, that is elimination reaction. Okay, so what is an elimination reaction? What is the general pattern of it? I'll show you first. The elimination reaction, suppose a molecule is this. We have carbon-carbon single bond, and one of the carbon atom has one leaving group attached here, and at beta carbon, this is alpha, this is beta, at beta carbon we have at least one hydrogen, right? And this is allowed to react with in presence of base, and we heat this. Right, and we heat this. This converts into C double bond C, an alkene, plus we get HB, and the leaving group goes out as L minus. Okay, this is what the overall reaction. Okay, so what happens in this? We have a compound, right? A compound on which we have a leaving group attached with one carbon, alpha carbon, and the adjacent carbon, beta carbon, we have at least one hydrogen, right? So condition for this reaction is what I'll show you first of all. The condition is at alpha carbon, presence of leaving group at alpha carbon, right? And at beta carbon, at least one hydrogen involved. At least one hydrogen. That is a necessary condition for this reaction. Okay. So what happens here? This sigma and this sigma, Cl bond and CH bond. This sigma bond breaks, converts into pi, and one sigma between the base and the hydrogen. Right. So what we can write here in this reaction, the characteristics is what? The first point, that 2 sigma bond, which is a stronger bond we have, 2 sigma bond converts into 1 pi and 1 sigma. See this? 1 pi and 1 sigma. Right? 1 pi bond and 1 sigma bond. Right? And that is why we can conclude from this, but sigma bonds are the stronger bond, and that is why the reaction is endothermic in nature. Endothermic means what? It receives heat. Okay? Endothermic in nature, delta H is greater than 0 for this reaction. This is the first property. The second property is the second property is if you talk about the entropy of this reaction, entropy means disorderliness. Okay, you just need to understand that entropy for this reaction is greater than 0, delta S is greater than 0, because one molecule converts into two molecules, then entropy increase, disorderliness increase. We'll discuss this term in thermodynamics chapter. Here just I'm taking these two reference to make you understand this, that the reaction is spontaneous. If you write down this term, delta G is equals to delta H minus T delta S. So for this two condition, at high temperature, delta G is less than 0, and hence the reaction is spontaneous. Feasible reaction. Okay. The reaction is spontaneous. Okay. So all these things, obviously you haven't done at this level, delta S, this formula and all, but this is not required to understand this. The point I'm trying to make is, for this reaction, we require higher temperature, that is it. Means we must heat it. Without heating, elimination is not possible, right? So what we do in this reaction, we heat it, means heating in presence of base. In presence of base. This thing, delta S, delta H, delta G, you haven't done. Okay, we'll do this in thermodynamics chapter. Okay, so you don't have to bother with it, with all this. Just you need to understand that high temperature is required for this reaction. Elimination reaction, we require higher temperature. Okay, that is the point here. Now this elimination reactions are of different types. We have E1, we have E2, we have E1CB, and we have EI reaction, intramolecular elimination reaction. Okay, but for this we are just concerned with E1 and E2. Okay, E1CB and EI, we won't do it here for KVPY. Okay, even these reactions we are doing some extra part of it, not very much important for KVPY, but like I said, there is not any defined syllabus, so little bit of understanding of elimination reaction we must have. Okay, however, the portion is not that important. Okay, but anyways, for exams like JEE and NEET, you have to understand all these things. So it's better that we understand these things before the exam itself. Okay. Okay. Now you see the first reaction we have, E1 reaction. E1 reaction. Okay. The E1 reactions, general reaction I have already given you, which is this: carbon carbon, one leaving group here, and one hydrogen present here in presence of base. If we heat this delta means we are heating it. It converts into an alkene plus HB plus leaving group goes out. This is the overall reaction. Okay. What is the mechanism of reaction? Okay. So the mechanism is, see, this mechanism is very much similar to SN1. Okay. SN1 reaction. E1 is very much similar to SN1 and E2 is very much similar to SN2. Like if you recall, in SN1 we have two steps reaction. The first step will get carbocation and the second step the attack of nucleophile. Here also, in the first step, we'll get carbocation, and the second step, nucleophile does not attack, but it is the base which extracts H plus from the beta carbon and forms an alkene. So in the second step, there's a difference. First step, it is same like we have this thing, formation of carbocation, right? The first step here is the formation of carbocation. So what happens in this, you see, carbon H here, carbon L, and in the first step, which is the RDS of the reaction, rate determining step, and this forms a carbocation. How? The leaving groups goes out from this plus L minus. Right, this is the formation of carbocation, and when carbocation forms, so there would be rearrangement also here, like hydride shift, methyl shift that we have discussed in SN1 reaction. All these things possible here also. Correct? Now in the second step, we have this carbocation, and the base takes H plus from the beta carbon, right? And this bond pair comes over here. This forms C double bond C plus HB. This is the overall reaction. Okay. Now, one thing is important here. We don't require very strong base over here, very strong nucleophile. Because if this base that you're using here, if it is very strong, very strong, then this would attack on this carbocation from which the leaving groups goes out. And we'll get there the substituted product, not the elimination product. Okay. So always remember this thing, that the base that is required here should not be that strong. Okay, that's why if you compare SN1 and E1 reaction, right, both are competitive reaction, right? Both has the same thing. First step is same only. In the second step, we'll have either elimination of this H plus or the attack of base on the carbocation. So if this base attacks on the carbocation, this will be a substitution reaction. If this base takes this hydrogen, it is an elimination reaction. Okay, so for elimination reaction, we don't require strong base. Okay, like if you ask me the order, SN1 reaction, if you see substitution reaction, that requires a stronger base than the base required for E1 reaction. That's the relative thing here. Understood this? So you should know the relative strength of bases, okay, that we can understand once we practice some questions, okay, the strong base, weak base and all, we can understand that. But yes, if you have the understanding of how the product forms, right, then you can think of SN1 or E1 reaction, okay. So for KVP, they ask very straight question. You don't have to get confused on this, that what reaction is possible here. that you can understand with the help of options given in the question. Correct. This is the mechanism of reaction. We get here an alkene and this. Okay. So what is the rate of this reaction? The characteristics you see. Few points here that order of the reaction is 1. Okay, that's why it is E1. Rate is again directly proportional to the stability of carbocation. First thing, more stable carbocation, more will be the rate. Okay, directly proportional to leaving group ability. Leaving group ability, and for this reaction, weak nucleophile is preferred. Base is preferred because if it is strong, it will attack on the carbocation. Right? Weak nucleophile is preferred. Right? Weak nucleophile, you can also take it as weak base. Fourth one, we require polar protic solvent for this. We require polar protic solvent for this. Polar protic solvents are those solvents in which oxygen-hydrogen bond is there. Right? Hydrogen is attached with an electronegative element. For example, we have H2O is a polar protic solvent. Alcohol is a polar protic solvent. Acid is a polar protic solvent. Phenol also we can take for this purpose, polar protic solvent. Ethers are polar aprotic solvent. Okay. So like I said, the steps are very similar to SN1. So in these reactions, there is a very close competition of between SN1 and E1 reaction. Okay. Like for example, you see, we have a compound, the same thing we are discussing here. This compound we have, where this has a leaving group. Here we have one hydrogen, and this is, the first step is the RDS. It forms a carbocation, single bond C, positive charge on it, and H. Now after this, what would be the product of the reaction? It depends upon what reagent we are taking here. Suppose we are taking a base, right, which is very strong base, and suppose we are taking base which is not that strong, weak, plus we are heating it also. Okay. If this is the case, means this would be a nucleophile, and the reaction here, it goes under SN1 reaction. SN1 reaction, and the product is CCB NH. This is substitution reaction. If it is a weak base and we are heating it, because elimination requires heat, okay, we need to heat the compound. So in presence of heat, elimination reaction takes place. So it forms C double bond C and the conjugate acid of this base. Okay. So substitution does not require any heating thing here, but elimination requires heating. Correct? That is how we can differentiate the two reactions. Okay, plus the base thing is always there. So that's what the meaning here, a close competition between SN1 and E1 reaction. Right? So these three are the favorable condition of SN1 and E1. Right? Like I said, formation of stable carbocation, polar protic solvent, and good leaving group. These three properties are common for both reactions, SN1 and E1 reaction. So if I write down here the favorable condition for SN1 and E1, because this relative understanding is very important for this reaction. Okay, so write down here the favorable condition for SN1 and E1 reaction. SN1 and E1 reaction. Okay, so the condition is what? The first one, it is formation of stable carbocation, Second one is polar protic solvent. And the third one is, like I said, it must have good leaving group. Good leaving group. Okay. It is the temperature only which affects the reaction, that whether it goes under SN1 and SN2. So depending upon the temperature, we'll have the reaction path, right, or the mechanism of reaction. So if the temperature is low, right, and if the temperature is high, means it is given in the question that we are heating it. That means the high temperature. High is E1 and low is SN1. That is what the difference we have here. Low means less than, we can say, 25 degrees Celsius room temperature. High means more than 50 degrees Celsius. Okay, elimination reaction. And this is the temperature I am giving here for halogens as the leaving group. Halogens as the leaving group. Right, halogen as the leaving group. If the leaving group is different, then the temperature may be different from this too, but higher temperature will be E1, lower will be SN1. That is always true, right? So mostly, we'll have this temperature thing mentioned for halogens only in our syllabus. That's why we have this value here. But if the leaving group is changed, the temperature will also change depending upon the leaving group. what happens if the temperature falls in this range, 25 degrees Celsius to 50 degrees Celsius. In this range, both SN1 and E1 favorable. SN1 and E1 reaction possible. So we'll get the product according to both, mixture of both products we get. Okay, now based on this, we'll see some examples. Suppose if they ask you, find out the total number of product. And the question is, the first one is this one. H2O, and we are heating it at 80 degrees Celsius. This is the first question. The other reactions we have, correct? So since you see, we're heating this reaction. The temperature is 80 degrees Celsius, 80 and 80 we have here. So all these reactions are E1 reaction. This is E1, this is also E1, and this is also E1. Here also we are heating it, however, it is not halogens, but since we are heating, it is also E1 reaction. Okay, if you do not heat, it may be E2, sorry, SN1. Okay, so in this reaction, what happens? The first step is the formation of carbocation. So we'll get the carbocation like this. And if it is possible to rearrange this to get the more stable carbocation, we'll do that. Okay, but here the rearrangement is not possible. We won't do that, right? And this is, you see, this is the beta carbon we have. This is alpha, this is beta, and this is beta. Beta and beta. So from beta carbon, we can eliminate one hydrogen, right? And the product would be this. One product is this, and another product is this one. Okay, so it happens how this hydrogen leaves this bond pair of electron and comes out. The base will take this hydrogen atom. Okay, same thing happens over here. Here, what happens? You see, we get a carbocation here, right? And in this carbocation, there would be there would be rearrangement. Okay. So here also there's no rearrangement possible, right? And that's why we eliminate H from here or H from any one of these two carbon atoms. So the possible product is elimination product is this, or we get this double bond. These are two products we get. Okay. Now in this one, what happens? This H plus comes over here, H2O goes out, and we'll get a carbocation in the first step, which is this. Okay. If you try to understand this H plus comes over here onto this lone pair of this oxygen, takes this H plus, so it is a protonation of this hydroxy group. And then we get here OH2 plus, and from that H2O comes out, we'll get a carbocation here. This carbocation is also a stable carbocation. We won't, rearrange this. Okay. Then either H plus comes out from this or from this carbon atom. Okay. So the product would be this. We have a double bond here. And one more possibility is we have a double bond here. This is the two product possible here, right? To answer. Here again, the product is, first of all, we get a carbocation. So leaving group you just remove and you add a positive charge in the same carbon atom. So we have CH3 here, and this is a positive charge. And from here, H plus comes out from the adjacent carbon by the base, right? So it is pH, then C double bond CH2, CH2, CH3, one product is this, plus we may also get pH, CCH3, double bond CH3. Okay, this is the two product we get in all these reactions. All these are elimination product. Okay, through elimination we get that even mechanism we have. Okay, so the reaction is not that difficult, but in the question it is, the difficult part is to identify whether the reaction goes under SN1 or E1 reaction, right? Because both have a very close competition here. Okay, now I see this question here. Suppose we have a molecule CH2 double bond, CH single bond, CH3, Br. And this is allowed to react with H2O at 10 degrees Celsius. And this is allowed to react with H2O at 80 degrees Celsius. The answer in these two reaction. Okay. So first of all, it is SN1 because it is 10 degree. SN1 low temperature. High temperature it is it is E1. So first of all, you should know this. E1 or SN1. So what happens? Both forms a carbocation first. So carbocation that we get here, CH2 double bond CH, single bond CH, CH3, and we have a positive charge on it. Now you see there is no shifting possible here. Otherwise, we'll get the lesser stable carbocation. This is the most stable carbocation we have here. No rearrangement. Because this carbocation is resonance stabilized here. Then H2O here behaves as a nucleophile. This will attack onto this carbon atom and it forms CH2 double bond CH, single bond CH, CH3, OH2, positive charge on it. So the nucleophile is H2O here. And from this H plus comes out from oxygen. One of this bond pairs drags to stabilize this positive charge, and hence it is CH2 double bond, CH single bond, CH single bond, CH3, and we have OH here. This is the product via SN1 mechanism. Okay, via SN1 mechanism. But if the temperature is 80 degrees Celsius, it is E1. So again, we get a carbocation here in the first step. So CH2 double bond, CH single bond, CH positive charge, and CH3. Okay. Now in the next step, from the adjacent carbon, H plus comes out. So we have this one, H plus comes out. So C double bond C will get here, and from here. So from here, H plus comes out. From here, H plus comes out, and it forms CH2 double bond CH, single bond CH, double bond CH2. So this is a conjugated product, a stable one. That's why this one forms. So H plus comes out from here, we'll get this. Okay. So this reaction, this product is via SN1 mechanism. Okay. Sorry, this one is via E1 and this one is via SN1. So you can see the same reaction, just one difference of temperature, how it can give two different products altogether. Okay, this is the two reactions. So I hope you understand the difference between the two. You have to be very aware regarding this, that how the reaction goes, what is the difference in the two reaction, and based on the difference, what is the possible reaction we have here, right? Okay. Now, the last reaction we have to discuss is E2 mechanism. E2 reaction. So E2 reaction, first of all, it requires, first of all, you see what is the reaction here. So same thing, carbon-carbon bond with a leaving group here and base, sorry, hydrogen atom present over here, and in presence of a base, we'll get an intermediate step, which is this C single bond C. This bond is about to break. This bond is about to form, and this bond is about to break, leaving group. And here we have H. This bond is about to form. So we'll get a transition state like this. Okay. This bond is about to break. This one is about to break again. This bond is about to form and this bond is about to form. So this is the transition state we get here. And I'm just writing it down for you to understand. It is one step reaction only. It forms for fraction of second, and then this converts into an alkene. C double bond C, BH goes out, plus L minus. Some of you must be thinking that this reaction is exactly similar to the previous one. Yes, it is. Like, the product, in terms of product, it is very similar. But the path of the reaction is not same. In the previous one, we have even mechanism, formation of carbocation takes place. That one is two-step reaction, it is single-step reaction, no carbocation formation. So E2 you can compare with SN2. Okay, E2 we can compare with SN2. Now the base that is required here, the required base is strong. Strong means the base must be, we need a stronger base in comparison to even reaction. Like the same thing we had in SN1 and SN2. Right? SN2 also requires a stronger base. This also requires a stronger base. Right? It is a single step reaction. Single step reaction. No carbocation formation. No carbocation formation. Rate is what? Rate is directly proportional to the stability of transition state. Okay, it requires a strong base. This is the thing. Okay, sorry for the interruption. Yeah, so requires a stronger base which can extract H plus from the beta carbon. That is the purpose we have, like we had in even reaction, right? So always remember this. Even in E2 reaction, the base always takes H plus from the beta carbon. Okay, what all the strong bases we have, because this is the actual thing that you should know, that if you do not know the property of the base, you won't get it right. So the strong base example we can have, we can take alcoholic KOH, strong base. Okay, we can take NaNH2, stronger than alcoholic KOH. NH3 also we can take. NaNH2 we write is a base, or the same reagent we can also write as sodium with NH3. That means NaNH2 only. Okay, we can take RO minus Na plus, strong base, in a solvent like alcohol. This is a solvent, we can take this base, or we can also take a bulky base which is O minus Na plus in a solvent like this, OH. This is 3 methyl group present here. 1, 2, 3 methyl group of carbon here. So it is isobutyl group actually. Sorry, tertiary butyl group actually it is. Okay. So this is the base and solvent in this. Like this, if you use base and its solvent, base and the solvent. So this is the relation here. You see, base and its solvent. Right? So this solvent must be the conjugate acid of this base. H plus we have to add over here, you'll get this. O minus, you add H plus, you'll get this. So these are the bases, are strong bases, which we use for SN2 reaction or E2 reaction. Right? Now the next thing is what? The solvent here, like SN2, here also the solvent required is polar aprotic solvent. Ethers and all we can take for this polar aprotic solvent. This reaction is also spontaneous at high temperature. Spontaneous at high temperature. Okay, so elimination reaction favors at high temperature always, right? Whether it is E1 or E2, high temperature is required. Okay, plus base nature also you must keep in mind, whether it is strong base or weak base, right? Okay, now the examples of E2 reaction. Examples of E2 reaction. The first one is dehydrohalogenation reaction. Dehydrohalogenation reaction. This means what? Removal of HX. mainly HCl, HBr, HI, dehydrohalogenation, right? For example, you see if you have a reaction CH3CH Cl CH3 CH3 alcoholic KOH. You know alcoholic KOH is a strong base and we are heating it. That is also required. Okay. So we are heating in presence of a strong base. The strong base plus we heat it, the combination gives you E2 mechanism, right? So the reaction mechanism is E2. So what happens in this? There is no intermediate, no carbocation formation into this. The base takes H plus from here or here. See, first of all, this carbon is the alpha carbon which is attached with the halogen. And the adjacent to alpha carbon, this is beta and this is beta. So this base can take hydrogen from any one of the beta carbon. So we'll get here two product. Okay. The first one is when this H plus comes out, right? This Cl minus taken up by this K forms KCl. When this H plus comes out, so we'll get a double bond here. So this would be CH2 double bond CH, and other things will be as it is CH, CH3 and CH3. Plus the other product would be when H plus comes out from this, it is CH3, CH double bond C, CH3 and CH3. Okay. Plus we'll get some more product into this one. K plus takes Cl minus forms KCl. OH minus takes H plus forms H2O. This is all the reaction. Okay. Now in this two reaction you see this one is the major product we have. Why it is major? Because the alkene is more stable. The alpha hydrogen is 9 over here. This alkene is more stable, hence major. This alkene is minor product because it is less stable. Alpha hydrogen, if you see, it is 1 over here. It is only 1, so this one is minor product. This major and minor understanding is important here. Okay, more stable alkene, means it is the major product. Less stable alkene, then it is a minor product. Major product means stable, means it will form more in the reaction. The composition of this product will be more, and this is the answer, right? And how do we compare the stability of alkene? Hyperconjugation. Hyperconjugation, how do we calculate that? We count alpha hydrogen to that, right? So alpha hydrogen is 3 plus 3 plus 3, 9 here. For this double bond, this is the only carbon which is the alpha carbon with respect to this double bond. This double bond, this is alpha, and this is alpha. So we have 3 alpha carbon and it has 9 hydrogen total attached to it. Here we have only 1, correct? So this is the major product we have. This alkene, double bonded carbon, has more number of alkyl group present with it. This alkene, we also call it as more substituted alkene. More substituted alkene. More substituted alkene you can compare and understand by this. Suppose I have taken ethene, CH2 double bond CH2, this one, and another one is CH2 double bond this CH3, correct? So if you compare this to, since one hydrogen is displaced by or substituted by methyl, so this alkene is more substituted than this one. Further, if one more hydrogen will substitute, like for example, this one you compare, CH double bond CH, CH3. So this one is even more substituted than this one. So if it is A, it is B, and this one is C. So substitution order, the one which is most substituted among the three is C, then B, and then A. This is how we see the substituted alkene. If the hydrogen is getting substituted, then this. Okay, so this is one thing. If I have discussed this here, you'll understand, right? Substitution. Now, this alkene, obviously, it is more substituted than the previous one. And the product which is more substituted, we call it as Setjeff product, Saytzeff. It is Setjeff product. And the one which is less substituted is Hoffman. Hoffman product. So Setjeff is the major product we have. The minor product is the Hoffman product. Must remember this term is very, very important. Okay, Setjeff and Hoffman. Again, I'm repeating, more substituted alkene is Setjeff, less substituted alkene is Hoffman. Okay, some more examples we'll see. CH3CH2 Br with alcoholic KOH, and we are heating it. The product would be CH2 double bond, CH2 and alkene, and there's only one product possible here. Right? If you have Cl here with the same reagent, it gives two possible product because we have two alpha hydrogen here. Two means two different alpha carbon. This is the another product, right? Which one is more major? Which one is Setjeff product? This one is a Setjeff product because it is more substituted and is stable. And this one is Hoffman. Setjeff and Hoffman. Okay, one very, very important example you see. CH2 double bond CHCl. Okay, with alcoholic KOH, and we are heating it. And this one with NaNH2, and we are heating it. So sometimes, you write down the product here as this takes KCl and H plus comes out from this, you'll get C triple bond CH. And this is the product here. And here also we'll write CH triple bond CH. Okay, but here what happens, this product is not possible. This is wrong. In fact, in this question, we do not have any reaction. Because you see, the lone pair on this chlorine is in conjugation with this pi bond, right? See here, this carbon chlorine bond has partial double bond characteristics, right? That is why this chlorine is difficult to extract because it has double bond characteristics here, right? So for this, we require a stronger base which can take this chlorine out. KOH is not that strong enough, alcoholic KOH. We need a stronger base than KOH. So KOH is what? KOH, however, it is a strong, but it cannot extract Cl minus from sp2 hybridized carbon. We require stronger than this. And for that purpose, we use NaNH2. So NaNH2 is what? NaNH2 is a stronger base, stronger than KOH. This information also you must have. Stronger base is stronger than Kf and capable of extracting capable of extracting Cl minus from sp2 hybridized carbon, right? That's why this reaction is not possible, but this one is possible. So to get an alkyne from this carbon molecule, this is vinyl chloride actually. The name of this compound is vinyl chloride. This position is vinylic position, this carbon. At vinylic position, the carbon is attached, it is vinyl chloride, right? So vinyl chloride, to convert into alkyne, we use a stronger base. Alcoholic KOH does not give this reaction. Answer with NaNH2 is alkyne. You must remember what is Sadjev and Hoffman product. On this, you may get question in KVI. This one is important. Sadjev product and Hoffman product. More substituted alkene is more stable and it is called Sadjev product. The lesser stable one is Hoffman, right? So these things are important. SN1, E1, SN2, E2 reaction. Okay. So I will request 2-3 times you have to revise this video so that you will be comfortable with the reactions given here. Thank you guys. Take care. Bye-bye.